Bismillahirrahmanirrahim. So here is a problem. Random variables x and y have the joint PDF. Fx comma y is equal to c, while x is greater than or equal to 0, y is greater than or equal to 0, and x plus y is less than or equal to 1. And this is 0 otherwise. And we are to find out, part A, what is the value of the constant c, what is the probability that x is less than or equal to y, and part C, what is the probability that x plus y is less than or equal to 1 over 2. So before we begin to solve this problem, let us plot this region of non-zero probability. So here we have, this is x-axis and this is y-axis, and x is greater than 0 means we are on the right side of this y-axis, and y is greater than 0, it means we are in this direction above x-axis. So it means this is the first quadrant, right? Then x plus y is equal to 1, is less than or equal to 1. So for this, we need to first plot this line x plus y is equal to 1. So x plus y is equal to 1. So when x is equal to 0, we have y is equal to 1. And when y is equal to 0, we have x is equal to 1. So x is equal to 1 when y is equal to 0, right? So this is this point here, and this point when x is equal to 0, we have here, right? So this is y is equal to 1 here when x is equal to 0. And this is the origin 0, y and x and y are 0 here. So it is this line basically, this line. So this is x1 and y0 here, and we have y1 and x0 here at this point. So this line is x plus y is equal to 1. So x plus y less than or equal to 1 is this region. Okay, so it is this region where this joint density function is non-zero. Elsewhere it is 0, right? So let's now begin to find out the value of this constant c. So we know that part A, the constant c. So for this to be a valid joint density function, the integral from minus infinity to plus infinity, the double integral fx comma y, x comma y, dx dy, it should be equal to 1, right? So let us evaluate this integral, and then we can find out the value of c this way. So the joint density function is a c here, right? And we are integrating in this order dx and dy, and it should come out to be 1. All right. So now the important step is to find out the limits for x here and then y here. So we are integrating first with respect to x. So we are assuming a horizontal strip, for example, somewhere here, which will move up and down. So x is 0 here, and at this point, x is bounded by this line. So x is 1 minus y here, right? So x, the lower limit is 0, and the upper limit is 1 minus y here. And the y, it moves from 0 to 1. The lower limit is 0, upper limit is 1 here. So we could have opted for a different order of integration, dy dx. In that case, limits will be different. So we will discuss that also subsequently. So first let us evaluate this integral. So y is equal to 0 to 1, and c is a constant. It can be taken out this way, and we are to first integrate with respect to x, and we have a x here, and the limit is from 0 to 1 minus y. We still need to integrate with respect to y, and it should come out to be equal to 1, right? So we have a c here, y is equal to 0 to 1 here, and we substitute the value 1 minus y minus 0, right? We leave the 0 out, dy, and that should be equal to 1. So now we are now to integrate with respect to the variable y. So c here, and we have a y here, right? Minus y square over 2, and the limits are from 0 to 1, and that should be equal to 1, right? So c, and let's substitute the values now. This is 1 minus 1 over 2, and that should be equal to 1. And this is c into 1 over 2 is equal to 1, right? So that means c is equal to 2. So the value of the constant c is 2. So as I described earlier, we can use a different order of integration just to demonstrate how to take limits. For that case, let us calculate that also. So alternatively, now this double integral in a different order, c here and dy dx, and that should be equal to 1, and this is the limit for y here now, and this is the limit for x here. So we are now integrating first with respect to y. So we are assuming a strip, for example, which will move from here to here, right? So the y is 0 here, right? And then up here it is bounded by this line, and y is equal to 1 minus x here. So 1 minus x here, and x is 0. We move this strip from 0 to 1 here. So this is 1. So x is equal to 0 to 1. The constant c is taken out, and when we integrate with respect to y, we get a y here with limits 0 to, this is 0 here, 1 minus x, and we are still left with integration with respect to x, and this should be equal to 1. So this is c, 0 to 1, the limits, and dx, and that should be equal to 1, right? So now c, and when we integrate, we get an x here minus x square over 2, and the limits are from 0 to 1, and this is equal to 1. And then we have c, 1 minus 1 over 2, and minus 0 that we leave out is equal to 1. So again, c multiplied by 1 over 2 is equal to 1, right? So that is c is equal to 2 again. The same answer that we obtained earlier, but with a different order of integration. So the value of the c is 2 here. So in short, we can write the joint PDF fx comma y, x comma y is equal to 2 when x is greater than or equal to 0, y is greater than or equal to 0, and x plus y is less than or equal to 1, and this is 0 otherwise. So this is our density function, the joint density function of the random variables x and y. So we are done with the first part of the problem. For the second part of the problem, we need to evaluate this probability that x is less than or equal to y. So let us plot this diagram again, but with this additional constraint now. So we have here the x-axis, and we have here the y-axis, right? And we have this line here, this constraint. So this is x is equal to 1 here, and we have a y is equal to 1 here. So it is this region we are interested. And x, this line is x plus y is equal to 1. And the third, to find out the region x less than or equal to y, let us just plot this line x is equal to y. So x is equal to y is this line here, right? So this is x is equal to y. So find out which region is x is less than or equal to y. So suppose, assume a point here, right? Any point here. And then find out estimated x and y coordinates. So you see that this x, size of this x coordinate is larger than this y coordinate. So here in this region, x is greater than or equal to y. However, if you assume, for example, see a point here, so the value of the x is smaller than the value of the y. So it is this region where x is less than or equal to y. So right, it is this region now that we are interested in. And it will be interesting and useful if you find out the coordinates of this point also, right? So at this point, actually, this intersection of two lines, x plus y is equal to 1 and x is equal to y. So both these equalities hold at this point. These are true at this point. So if we put x is equal to y here, we get 2y is equal to 1 and y is equal to 1 over 2, right? Y is equal to 1 over 2 at this point. And if we substitute y is equal to x here, then we get 2x is equal to 1 and x is equal to 1 over 2. So this is x is equal to 1 over 2 here. So the coordinates of this point are 1 over 2, 1 over 2, right? So now the probability that x is less than or equal to y is given by this double integral. We need to integrate this joint density function dx dy over this region. X is less than or equal to y. And we can use any order of integration. We can use dx dy or we can use dy dx. But if we look carefully, if we use this order of integration dx dy, then we are assuming a horizontal strip here, for example, right? So on one side, this strip is bounded by x is equal to 0. On the other side, this is bounded by this line where x is equal to y. And we move this strip from here to here, then these limits remain valid. But as soon as we move beyond this point, y is equal to 1 over 2 here, for example, then on this side, it remains bounded by x is equal to 0, but on this side, the boundary changes. The boundary is now x plus y is equal to 1. So x will be 1 minus y here, not x is equal to y like this here. So if we use this order of integration, then we have to split the double integral into two integrals, the summation of two integrals. So to avoid this, we can try integration in this direction, for example, in the vertical direction. So this vertical strip will move from x is equal to 0 to x is equal to 1 over 2, right? And this strip is bounded on the lower side by x is equal to y, and on the upper side, y is equal to x, and the upper side by y is equal to 1 minus x. So it will be just one integral. So let us try this out, this integration in this direction, y direction first. So let us write down the integral. So we have this probability that x is less than or equal to y is equal to given by this double integral, and we are integrated with respect to y first, right? And x is equal to, here we will find out these limits later. And the value of the joint density function is just 2, right? So this is 2 here, and dy and dx, we are integrating with respect to y first. For the reason I told you earlier, because this will be a single integral, otherwise we will have to split the integral into 2. We can work on that one later on, just for the sake of a demonstration that how to take these limits in that case, in the other case. So let's work with this one first. So y is equal to, as you see from this diagram, now y is equal to x here, and y is equal to 1 minus x here on this side. Y is equal to x here bounded by this line, and y is equal to 1 minus x here bounded by the other lines. So y is equal to x, and y is equal to 1 minus x here. And the x is 0 here, and till here it is 1 over 2. So x changes from 0 to 1 over 2. So we can take the constant out. So x is equal to 0 to 1 over 2, and we have y here. So we get a y by integration with respect, and the limit is y is equal to x, and y is equal to 1 minus x here. And we are still left with integration with respect to dx over 2, and let's put the values 1 minus x and minus x. So that will be 1 minus 2x, and then we get a dx here. So again, we have 2 here, then x minus x square over 2. So that 2 will cancel out with this 2. So x minus x square, and the limits are from 0 to 1 over 2, right? So this is 2 here, and now let's put down the values. 1 over 2 minus 1 over 4 and minus 0, 0. We leave that out. So this is 2, and 1 by 2 minus 1 by 4 is again 1 by 4. So 1 by 4. So that is 1 over 2. So the probability that x is less than or equal to y is 1 over 2. Right? So this is when we assume the order of integration dy dx. But if we take the different approach, the other approach, so as I told you earlier, we will have to split the integral into 2, but do that anyway, just for the sake of demonstration. So probability alternatively, yeah. So probability that x is less than or equal to y is given by, now we are integrating first with respect to x and then with respect to y, right? So here, this is in this region, x is equal to 0 here, and then x is equal to y here, right? Bounded by this line, x is equal to y here. X is equal to 0 to y, right? And y is equal to 0 until here it is 1 over 2, because after that, after 1 over 2, when y moves further straight, move this straight only from 0 to 1 over 2. So y is equal to 0 to 1 over 2, and we have the joint density function 2, and this is dx dy, and now the other integral, we have to use the integral sum, the other integral. So x limits and y limits that we will determine for this case now, and the value of the density function 2 dx dy, they remain the same. But you see now x is, and this strip moves from y is equal to 1 over 2 to 1. So y is equal to 1 over 2 to 1. So As I described earlier, this is now the summation of two integrals. So the two can be taken out. Y is equal to 0 to 1 over 2, and we get an x here after integration, and the limits are 0 to y, and we have dy here still, plus this 2 taken outside. Y is equal to 1 over 2 to 1, right? And we have an x here, and x is equal to 0, 1 minus y, and dy. Here we have 2, and y is equal to 0 to 1 over 2, right? And when we make the substitution, x, we have a y here, right? And dy, right? And this other integral plus 2, we have uh, y is equal to 1 over 2, y is equal to 1 over 2 to 1, right? And 1 minus y, minus 0. So 1 minus y dy. Okay, so let's now move forward. So this is y square over 2, 2 into y square over 2, right? And the limits are from 0 to 1 over 2. And plus we have 2, and this is y here, and minus y square over 2, and the limits are from 1 over 2 to 1. So this cancels out, and we're left with substitution of 1 over 2 into y square. So this will be 1 over 4 plus 2, and let's substitute this value here now, 1 minus 1 over 2, right? And minus 1 over 2 here, and minus 1 over 2 squared will be 1 over 4, and divided by 2 it will be 1 over 8, right? So this is 1 over 4 plus 2 into 1 minus 1 over 2 minus 1 over 2 plus 1 over 8. So this is 1 over 4, and plus this is 1, and this is minus 1 over 2 minus 1 over 2 will be minus 1. So this cancels out with this, right? So we're left with 2 into 1 over 8, so that will be 1 over 4, and that should be 1 over 2. So the probability again comes out x less than or equal to y is again the same value, 1 over 2, that we determined earlier, but now in a different way, right? So we are done with part B now also. The part C now. What is x plus y is probability that, what is the probability that x plus y is less than or equal to 1 over 2? So part C, probability that x plus y is less than or equal to 1 over 2. We just need to determine this probability now. So let us plot that diagram again, and this with the distant constraint here. So this is x, and this is y, and we have this line here, right? This is x plus y is equal to 1, and this region is x plus y less than or equal to 1, right? And we have this, let's draw this line now. X plus y is x plus y is equal to 1 over 2, right? So if we substitute y is equal to 0 here, right? So then x is equal to 1 over 2. Somewhere here, 1 over 2. This is 1, you see, x is equal to 1. This is y is 1 over 2. X is equal to 1 over 2 here. And if you put is equal to 0, you get y is equal to 1 over 2. So this is somewhere here, y is equal to 1 over 2. So it is basically this line. and x plus y less than or equal to 1 over 2 is this region. So again, it can be calculated in two ways. So y dx dy, and we need to integrate over this region, right? So let us uh, now integrate using x first. So we are assuming, for example, a horizontal strip here, right? So this integral is now given by, so this will be the limits of x, these will be the limits of y, and fx comma y is 2, if you remember from our previous calculations. So this is 2 here, right? So 2 and dx and dy. So x is a 0 here, right? And this line is x plus y is equal to 1 over 2. So this is x is equal to 0 and x is equal to 1 over 2 minus y. 1 over 2 minus y here, right? This is the upper limit, and y varies from 0 to 1 over 2. So these are the limits of integration, which should not be difficult to evaluate, right? So this 2 can be taken out, right? This constant, and we have y is equal to 0, and the upper limit is 1 over 2, and we integrate with respect to dx, we get an x here with limits x is equal to 0, right? X is equal to 0 here, x is equal to 0, right? And 1 over 2 minus y and 0, right? And we still still to integrate with respect to y. So this is 2, and y is equal to 0 to 1 over 2, and this is 1 over 2 minus y minus 0, leave 0 out, so dy here. So this will be 2, right? And this will be 1 over 2y minus y square over 2, 0 to 1 over 2. So this 1 over 2 can be taken out. So this will be 2 over 2 y minus y square with limits 0 to 1 over 2. So this cancels out. So this will be 1 over 2 minus 1 over 4. So that is basically 1 over 4, right? So probability that x plus y is less than or equal to 1 over 2 is equal to 1 over 4. So this integral can also be evaluated, this part C, using a different order of integration. So let's do that as well. So let me say alternatively, we can calculate it in a different way also. So the probability that x plus y is less than or equal to 1 over 2 is given. And now the limits of y here and the limits of x here, right? So the limit of y, let's look at this diagram here. We are now assuming this strip here in this direction. So y is equal to 0 to y is equal to 1 over 2 minus x here. So y is equal to 0 to 1 over 2 minus x, and x is from 0 to 1 over 2. 0 to 1 over 2. So these are the limits of integration now. So 2, this constant can be taken out. So x is equal to 0 to 1 over 2 here, and integration with respect to y gives us a y here. It's from 0 to 1 over 2 minus x and dx, right? So this is 2, x is equal to 0 to 1 over 2. This is 1 over 2 minus x minus 0, and dx. And this is 2, and we get 1 over 2x minus x square over 2, right? And 0 to 1 over 2. So this is, we take this 1 over 2 common outside, 1 over 2 here. So this is x minus x square, 0 to 1 over 2. So basically, this is 1 over 2 minus 1 over 4. So again, this is basically 1 over 4. So the probability that x plus y is less than or equal to 1 over 2 is equal to 1 over 4. So this finishes our solution to all the 3 parts of the problem, and we have done all the 3 parts using 2 methods to demonstrate how to take limits in either case.